All right, today we're going to talk about specific heat and heat capacity. So, if you go to the beach, you'll notice that the sand is super hot, yet the water is a lot cooler. And if you think about it, though, they've all been receiving the same amount of heat from the sun, right? It's not like the sun has been heating the sand up more than the water. And so, what we figure out is that somehow the water is able to absorb more of the heat, and so the temperature gets raised more slowly than the sand. The sand's it's not able to absorb more of the heat. In fact, so the temperature of it increases quite a bit. And so this is what we call a specific heat capacity. So the technical definition is the amount of heat energy required to heat 1 gram of substance 1 degree Celsius. And so from our previous example, it takes a lot of energy to raise a gram of water 1 degree Celsius, where it doesn't take a lot of energy to heat the sand itself, right? And so which one has a higher specific heat, aluminum or water? Well, if you think about it, if you're boiling water or you're putting aluminum on, say, a hot plate, and you apply the same amount of heat, the metal will heat up a lot faster, which means it has a lower specific heat. Why? Because it's easier to heat up. And then water has a higher specific heat. Why? Because it requires more energy to heat up 1 gram of that substance. And then when you cool down, the opposite, because the water now holds a lot of energy, right? It will cool down slower, while aluminum will cool down a lot faster. So how do we solve for specific heat? It's this equation Q equals mc delta T. So let's talk about the variable. So Q is a variable for heat energy, and it's measured. There's 2 measurements you can use. Usually we use joules, which would be in a capital J, and then we also use calories, which we see. Calories actually is the unit used like on food, right? So they talk about burning calories, that kind of stuff. Mass is going to be, M is mass, which is going to be in grams. And then C is your specific heat. Specific heat is usually going to be measured in joules per gram times degrees Celsius. And then delta means change. So this is your temperature. So the temperature would be the final temperature minus the initial temperature. And this is usually in degrees Celsius. We don't really worry about Kelvin. All right, so let's do some practice problems. So the specific heat of wood is 2.03 joules per gram times degrees Celsius. How much heat is needed to convert 550 grams of wood at negative 15 degrees Celsius to 10 degrees Celsius? So Q equals mc delta T. So Q is the heat. That's what we're looking for. So this is how much heat. Our mass is in grams, 550 grams. And I might notice, I'm going to tell you that the units has to be in grams, and then the specific heat is going to be, here it says 2.03 joules per grams times Celsius. And so actually something that it's useful is whenever they give you specific heat, it also tells you the units you have to use. So notice the mass has to be grams, your specific heat has to be in joules, and your temperature has to be in degrees Celsius. So let's talk about the temperature. So the temperature, or the change in temperature, is your final minus initial, right? So your final is 10 degrees Celsius, right? And then your initial is 15 degrees Celsius. So you're subtracting by so once you do it like that plus thing, right? So that's going to equal 25 degrees Celsius. All right, so now you have everything. You just got to plug it in. So Q equals M times C, so 550 grams times 2.03 times 25. So this equals so I'm going to use, it looks like we're using 2 sig figs here, so it ends up like 27,912, right? But it's going to be about 28,000 joules. Well, how do I know it's in joules? Because in my specific heat, it has to be joules. Okay, here's another problem. What is the specific heat of a substance that absorbs 2,500 joules of heat when a sample of 100 grams? Here's the change in temperature, so we know it's got to be Q equals MC delta T. Q is given to you. Q is 2,500 joules. The mass is 100 grams. We want to figure out the specific heat, and the temperature is going to be, so the final is 70 minus 10, so that'll give you 60. So you have Q, 2,500, equals the mass, which is 100. You want to figure out C, and then you want to do delta T, which is 60. So C will equal, I know this is 1 sig fig, but let's just at least do 2. So 0.42, and it's going to be joules per grams times Celsius, right? Okay. The next one is this one here. This is how many grams of water, so we're solving for M, right? So do your thing. Q equals MC delta T. So the Q is 2,200 joules. The mass is what you want to figure out. C is 4.18 joules per grams times Celsius. And your difference in temperature. So it's going to be 100 degrees minus 34 degrees, which equals 66 degrees Celsius. So then we go Q equals MC delta T. Q is 2,200 joules. The mass you want to figure out, C is 4.18. And then the change in temperature is 66 degrees Celsius. So the mass is going to be, let's say, it looks like 8.0 grams. Yep. All right. So we can actually, if we have an unknown metal, we can calculate the specific heat of an of an unknown metal. And the way it works is we use calorimetry. So let's say we have a insulated, it has to be insulated because you don't want heat to escape. You just want everything to be contained within the system. So let's say you have a known amount of water, and you heat up a metal to a particular, so we have a metal here, and we don't know the specific heat, but we know, we can figure out, we know the mass, we know the temperature that you're going to heat it up to, and so we can dump this metal in the water. And so if we heat the metal and the metal is more, it's hotter than the water, what happens is the heat energy will go into the water, right? And then what will happen is the temperature of the water will increase. Well, the amount of heat, so remember Q is the heat, right? So what the key part here is the Q of the metal. So the amount that the metal releases, the amount of heat the metal releases, will also equal the amount that the water absorbs. So since the metal is releasing heat, we're going to call it negative. And then the amount of water, the amount of heat that the water absorbs is going to be, so better explained is, so hot metal goes in water, the water temperature of the water increases. Why did the temperature of the water increase? Well, it's because because the water absorbed heat, right? Well, where did the heat come from? Well, it came to the heat came from the metal. So the amount of heat that the metal loses, which is right here, right, is going to be equal to the amount of the heat the water gains. And so the reason why we need a styrofoam cup or something that is really insulated is because we don't want any of the heat. We want to measure the heat that is released. Okay, so let's do an example problem. It says 73.5 grams of aluminum is heated in the boiling water to a temperature of 98.7 degrees Celsius. Aluminum is then placed in a calorimeter containing 1,500 grams of water at a temperature of 25.40 degrees Celsius. The temperature of the water in the calorimeter increases to a final temperature of 28.20 degrees Celsius. What is the specific heat of aluminum? So we're going to break it down into two things. So the two things we'll break this down into is you can figure out the heat of the water first. Okay, so the heat of the water we can figure out because we have all the information. So let's do that first. So let's figure out. So we have 1,500 grams of water at a temperature 25.4, and then it increases to this, right? So the specific heat of water is a number that you could remember. So let's say, so we're going to figure out the water first. So Q equals, we don't know Q, we want to figure out that. We know the mass is 1,500, and then the specific heat of water is 4.18 joules per gram times Celsius, and then the change in temperature is going to equal, now the final temperature of the water is 28.20, right? So 28.20 minus the initial 25.40. So this equals 28.20 minus 25.40 equals 2.8 degrees Celsius. So Q of the water is going to equal 1,500 times 4.18 times 2.8. So that equals 1,500 times 4.18 times 2.8. That equals 17,556 joules. So water absorbed that much joules. Well, that means that this is how many joules that was given off by the water, right? Or by the metal. So we now know we can use this equation to figure out the other side, so the aluminum. So we now know the Q is, now it's going to be negative because, remember, negative means that it gave off the heat, right? So the negative means this is a positive because the water absorbed it. Because the aluminum lost it, we make this a negative. The mass is 73.5 grams, right here, of aluminum. So now I'm doing the aluminum. And now I know how much heat the aluminum lost. I have to figure out my specific heat of aluminum. The change in temperature, so the final temperature was 28.20, right? Or final minus initial, minus, and this was the initial temperature, 98.7 degrees Celsius. So that's going to equal, so if you take 28.2, you're going to get a negative number. Minus 98.7 equals negative 70.5 degrees Celsius. So let's set it up. So Q equals, so our Q is negative 17556 joules, right? Equals, our M is 73.5. We're going to figure out C. So that's C, and then negative 70. Let me rewrite this. So we have negative 17556 joules equals the mass, which is 73.5, times C times negative 70.5. All right, so then we can just solve for C. So 17556. So C will equal 3.39 joules per grams times Celsius. So that's for aluminum. Okay. And then there's another problem that you can try to solve. So you first have to figure out so it's the same thing, except now we're going to figure out the mass of the metal. So first we do the water part. So we want to figure out the Q of water. Our mass of water, it says, is 140 grams. And its temperature before adding the metal is 16. So, by the way, 4.18 joules per gram times Celsius. The change in temperature is, so it's the final is 17.6 minus 16.0. And that's going to equal 1.6. So let's solve for Q. Q equals 140 grams times 4.18 times 1.6. All right, so this equals 140 times 4.18 times 1.6. This equals 936.32. What's that? Joules. So then let's do the water part. So the water is our Q equals negative 936. Remember, the water absorbed 936, which means the metal gave off that amount. We know the mass of the metal to be, that's what we got to figure out. We know the specific heat is 0.460, and then the change in temperature, well, it ended up at 17.6 degrees Celsius. Now, that's the temperature of the water, but if you think about it, the water, after a while, eventually the water and the metal will end up at the same temperature, right? It will reach what we call kind of like an equilibrium. It started at 100 degrees Celsius, so 17.6 minus 100 is negative 82.4 degrees Celsius. All right, so we got Q equals MC delta T. So our Q is negative 936.32. The mass we don't know. The C is 0.460, and then the delta T is negative 82.4 degrees Celsius. So if we do the math, 82.4.460. So our mass is going to equal 24.7 grams. Good. This is extra practice with a key.